Welcome back. We said we're going to do factorization in this section. Now, let's just think, what is a factor? Okay, let's get right into it. A factor. What are the factors of 32? Let's look. The factors of 32. Okay. Factors of 32 are 1, 2 is 3, no. 4, what am I doing? Okay. 4, okay. 5, no. 6, no. 7, no. 8, yeah. What am I doing? 16 and 32. These are all, a factor is the thing that divides into it, leaving no remainder. So it's the thing that, for example, a factor of 16, 8, it divides in exactly twice. 16 is a factor, it divides in exactly once. So a factor is the thing that divides into something, isn't it? That's what we're looking for. So let's have a look at this situation here, shall we? You remember we for example, we multiplied out two brackets, okay? Let's say we did x minus 3 and x plus 2. Let's multiply this out as we did previously, shall we? Okay, there we go. We said then, we take the first one, is x times x is x squared, it's a plus, okay? And it's going to be plus 2x minus 3 times 1 and an x, and it's minus 6. Then we group like terms and we say x squared plus 2x minus 3. Please, if you need to, use the thing. Where are we? I'm at plus 2 and I'm going back to minus 1. Okay, minus x minus 6. Can you see that? X squared minus, well, let's just think, what did we do? We simplified. Okay, so we simplified. Okay, now what if I said x squared, right? What if I said x squared minus x minus 6, and I then say, okay, how do you get back to this x minus 3, x plus 2, right? In other words, ladies and gentlemen, what is the reverse? What is the reverse process of multiplying out? Okay, the reverse process of multiplying out is called factorizing. Factorizing is the reverse process of multiplying out. Okay, that's let's just keep that as a definition. Now, what I'm going to do is just hold that in your mind for a second. Okay, so when we factorize, we are doing the reverse of multiplying the brackets out. So if I had a 2x and I had here an x squared minus 3, let's multiply it out. 2x is plus 2 times 1 is 2, x cubed minus 3 is minus 6x. Correct? I have multiplied out using that process that we agreed we would do, using the bridges. This thing is now, I now say, right, I want you to do the reverse. I want you to factorize this. Okay? How do you factorize it? Well, there's a series of steps we're going to go through. Okay? And first of all, the step that we're going to start off with is you always look for them. Okay? You keep going through the same checklist. All right? Step 1. Let's write it down as step 1. All right? Step 1 is look for highest common factor, which means the highest thing that divides into both terms. Okay? Well, Does a 2 divide in there? Yes, it does. It leaves us with a 1. Does a 2 divide in the 3? Yes, it does. It leaves us with into the 6 leaves us with a 3. So the highest common factor is the highest element that can divide into the other, leaving no remainder. Okay? Very important, leaving no remainder. Okay? So it's got to be an integer, essentially a whole number, as we want to call it that, right? So the highest common factor is, let's have a look. Now let's go back. Let's say, right, let's look at this 2x cubed. They have said 2x cubed minus 6x. Factorize. What do I do? First look at the number, okay? Let's just leave sign. Let's look at the number first. All right. Does 2 go into 2? Yes. Does 2 go into 6? Yes. 2 is a factor. It's the highest factor because I can't go more than 2. Because if I go 6, I'm going to end up with a fraction. So I take out a 2. That leaves me with, essentially, this is what we're doing, isn't it? Okay, let me actually do that in a different color. Minus 6x over, I've got my factor 2, right? Can you see? All right. What have we got? There I've divided each one by 2, which means I'm left with a 2x cubed minus 3x, because that 2 goes into there 3 times. And if I multiply this bracket out, that 2 will cancel out. So when you take out your factor, divide each term by that factor. Now let's look at the variable. Okay. Yes, you're going to do this all in one, okay, eventually. Just build up your speed as you go. Next, you look at the variable. In other words, when we're doing it all in one, we're going to mentally say, okay, which is the highest number I can take out? Which is the highest variable I can take out? Okay, that's an x cubed, which means I can divide it by x, and I can divide that by x. So there's an x now. So what have we done? We've divided by an x, haven't we? And what are we left with? X squared minus 3. And can you see we are back to where we started? We have factorized it. The most important is highest common factor. That's what we're looking at in this scenario, right? Highest common factor. Next, okay, is, okay, we can look for highest common factor in many things, all right? Let's have a look at this one. All right, let's have a look at another example here. Let's have a look at another example. Let's say 9x squared y minus 45 xy squared. Let's look at the numbers first. Right. Can 3 divide into 9? Yep, can. Can 3 divide into 45? Yes, it can. Well, hang on. Let's have a look. Can 9 divide into 9? Yes, it can. Once, leaving 1. 9's into 45? Yeah, 5 times. So I can take out 9. Okay? You've got to go with the highest one you can get to. This is it's just practice. That's all this is. Follow the recipe every time. Now we say, okay, in other words, I'm going to divide each one of those by 9. That leaves me with 1x squared y, doesn't it? Okay? Because that's cancelled out. Minus 5xy squared. Okay? Now let's look at the first variable. Let's focus on this guy now. Okay? There's an x squared, there's an x. The highest I can take is an x, not an x squared. I can't take, because if I divide x squared here, let's have a look. 5xy squared over x squared, it means that'll cancel and leave me with an x at the bottom. So when you're doing these, okay, it is the lowest exponent that you can take out. So it's actually 9x. It's a little contra to what you would think, but it's the smallest exponent. We'll do another one, I'll show you. Okay, so x, okay. So I've divided both sides by x, haven't I? What happens here? X squared divided by x? is x times x over x, isn't it? That is x squared, right? What is this? It's x. So that leaves us with an x, y minus 5. What is x over there? Is times 1 times y squared. Generally, we don't write the 1. I'm doing it here because why? Because we're going through the steps of building it up. Okay? At some stage, after factorization and so forth, okay, every now and again I'll come back to that, but we're going to start dropping all of those interim steps now. So what do I do next? Next I say, right, then I look at my next variable. Can I take out? Yes, y is the highest I can take out. Y, so I've divided everything by a y. So what is this? Leaves me with an x minus 5y. Because on this side I've got y squared over y, which is y times y over y, which is y. Okay? Which is why we've now called it factorizing. Okay? So we have factorized that. Okay? Okay, happy with that? You can always check by multiplying it out. I'm not going to bother to do that right now. Okay? What are we going to do next? Well, the next thing we're going to do is we're going to look at something different. Okay? That's a highest common factor. For example, what's the highest common factor? X cubed y to the 5th minus 3x squared y 4. Well, let's look. What's the highest x? First, the numbers. There's no numbers, right? Let's put in a 27 here, which means, yes, I could take out a 3 because that's 9x cubed y 5 minus x squared y 4, right? You happy with that? Because 3 9s are 27. Okay. Next, I can take out, let's look at the first variable. The top is the x squared I can take out, right? So it's going to be 3x squared, and over here, 9. What am I doing? Dividing by x squared, right? That leaves me with x, y, 5 minus, that cancels, y, 4. Okay? Yes, I am going fast. That does look like a G. 9x, y to the 5. All right? Now I look at the next one, the y. 3x squared. I can take out y to the 4th. Leaving me with 9xy minus, what happens over here? What is y to the 4th over y to the 4th? It's y times y times y times y over y times y times y times y. Boom, 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 boom. Leaves us with 1 over 1, which is 1. Okay? Straightforward. Okay? As I say, these are really, I'm trying to sort of really get to the nitty-gritty and the core of these, some of the more difficult ones, just to go over the recipe. That's the main thing in this. Right, let's have a look. Here I'm going to do something now. This section is going to be called, it's in the second thing in factorization, difference of two squares. Okay? Difference of two squares. Right. What do we do here? The difference of two squares? Well, quite simple. Let's just have a look at something. This thing looks like this. Generally, in the books, you will see it as a squared minus b squared. Well, first of all, the word difference means minus. The word difference means minus. It means subtract. So if you've got two terms with a minus between them, it could well be the difference of two squares. What is the test? The test is it is something squared minus something else also squared. Okay? The test is A and B must be perfect squares. In other words, we must be able to get a square root of it without a decimal. So for example, if it's x to the fourth, what is the square root of x to the fourth? X squared. What is the square root of 4x to the 4? Is 2x squared, right? Because we can split it. We can say it's root 4 times root x to the fourth, okay, is 2x to the x squared, right? So that's a perfect square. Is this root 3x squared? Well, no, because that is going to be, yeah, x times root 3, because I can find the square root of that, but I can't find, that's a 1.732. It's a decimal, so the answer is no. It is not a perfect square. So therefore, we look and see two things with a minus, test for difference of two squares. Let's have a look at this. Okay, let's have a look at an example. Okay, the examples here are 1 over 9x squared minus 1 over 4 y to the power of 4. Let's look. First of all, always check for step 1. Highest common factor. No, there's nothing I can divide in there and there that'll leave me with a remainder, right? Or in there either. There's nothing common in either one. So therefore, my next port of call, is it two things squared, okay, separated with a minus? Well, there's a square and that's a 4, so it's something squared. So what is this looks like a squared minus b squared. A is the square root of term 1. B is the square root of term 2. So what do I do? The first thing I do is I say, right, what is A equal to? The square root of x squared over 9. Remember, 1 over 9 times x squared is x squared over 1. Multiplying, that's 1 times x squared over 9 times 1, which is x squared over 9, isn't it? What is the square root? I can take it to the top, square root of x squared over the square root of 9, which is x over 3. Let's look at the next one. It is 1/4, and once again, it's y to the 4th over 4, which is y to the 4th over 4, which is y squared over 2. So now I know that it is in fact a perfect square. Okay? So what do I do next? Right? Well, quite simply what I do next is I say, okay, now there's a specific formula. Okay, this is the general formula for difference of two squares, right? It looks like a squared minus b squared. Factorizing it, step 1, open two brackets. Step 2, put in a plus, put in a minus. Step 3, put in the square root of term 1 over there, and the square root of term 2 goes in there, and there and there. So let's have a look. Okay, we said it was going to be 1/9. Okay, well, I've done it up top, so I don't want to redo it because of time. So let me just scroll down. You can see here, let's have a look. Let's go back to our formula, shall we? Okay, there it is, right? We said A was x over 3. A equals x over 3. And B is equal to y squared over 2. And my formula was A plus B, A minus B. All right? So therefore it's going to be x over 3 plus y squared over 2 and x over 3 minus y squared over 2. Okay, let's just go back to the next sheet. What did I have there? Remember, there it is going to be a plus b, a minus b. Because a is the square root of a squared. B is the square root of b squared. Okay. In other words, you do it with a formula. All you have to remember is the simple formula. Difference of two squares breaks down, number one, into open a double bracket. Number two, square root of the first term, square root of the second term with a plus and a minus between. Let's have a look at a different one, okay? Without a calculator, what is the determine square root, or rather 100 squared minus 81 squared without a calculator? These are the kind of problems that they love to give. But they're the problems that are 3-4 marks, but they're actually quite simple because once you've seen it, you never forget that's the difference of two squares. That is a squared minus b squared, isn't it? So when you've got a funny one here, you say, hang on, when in doubt, factorize out, okay? When in doubt, factorize out. Look to see if we can factorize. Highest common factor, Secondly, difference of two squares, yes. That is going to be 100a minus b times, let's make it plus, a minus b. 100 plus 81, 100 minus 81, which is 181 multiplied by 19. Okay? Then you're going to multiply that out. You'll do your 181, 19, whatever, and your answer comes to 3439, right? What do we mean by all this? Well, that's the difference of two squares, isn't it? Here's another example for us on the difference of two squares. Okay? Difference of two squares. Here's one. 1/4 factorize. Okay? 1/4 times x squared y cubed. Okay? I've already 1/4 x squared y cubed. Okay? Minus 1 over 16 x cubed y squared. Oh my goodness, you say. Sure. Okay, first of all, let's look for highest common factor, shall we? Hold on, that a quarter goes, yes, of course it does, right? I can take out a quarter, can't I? Because a quarter goes, leaving me with 1 x squared y cubed minus 1 over 4 x cubed y squared. Let's look now. I can take out of this one, the biggest x is an x squared, correct? And the biggest y is a y squared. So I'm actually dividing by x squared y squared and x squared y squared. So over here I've got x squared over x squared, cancels out 1. Y cubed over y squared leaves me with y. Minus 1 over 4 times x squared x cubed is an x on top, and the y squared cancels out, and that's what we are left with over there. Okay? That's as far as that one goes. Now let's change it slightly, shall we? To this. Factorize. Factorize 1/4 x y cubed minus 1/16 x cubed y. Okay? Now let's have a look. What can we take out? First of all, step 1, highest common factor. Let's see. HCF. Yep, I can take out a quarter again. Then I can take out an x. And I can take out a y. Because there's the y common to that. Leaving me with 1 times that. X is another 1, correct? Y squared. Correct? Minus 1 over 4 times the x goes in there, x squared, and the y cancels out that, and I'm done. So let's rewrite this as 1/4 xy times y squared minus x squared. No, we're not finished. You'll see from the marks on the side, this one will be like maybe 4 or 5 marks, right? That's not worth that much, right? So what do? We always look. As you're factorizing, look again. HCF done. Now look for difference of two squares. Yes, there's my a squared and my b squared. So we've got 1/4 xy, right? open two brackets. Square root of the first term is y, plus and a minus, x, y minus x, like so. Okay? As another one, right, down over here, let's look at this. Let us factorize this one. Okay? Oh, not x, my bad. Look what Kevin forgot to do. See? He's in a hurry, he forgot the quarter there. So that's over 2. Okay? That's x squared over 4. That's over 2, and that's over 2. Sorry, my bad. Can you see that coming in there? Okay? It's the half, right? Because I've got a quarter. All right? Let's have a look at the next one. X to the fourth minus y to the fourth. X to the fourth minus y to the fourth. Whoa, what do I do here? I've never seen fourths before. Well, let me look. Highest common factor? Nuh-uh. There's not a number or a variable that can go, because there's no variable common to each term. So what do? I then say to myself, okay, that doesn't look like that. Difference of, well, it must be difference of two squares. So what is the square root of x to the fourth? That must be a, right? And b is going to be the square root of y to the fourth. That's going to be x squared, and that's going to be y squared. So it's a perfect square. So, hey presto, open two brackets, put a plus, put a minus. This is a plus b, a minus b, x squared, y squared, x squared, y squared. Now, hold on. Look at that. That's the difference of two squares again, isn't it? So if it's the difference of, we've got to keep going. X squared plus y squared. That one is going to be, it's a difference of two squares, open two brackets. Put a plus, put a minus between. Then a is going to be the square root of x squared. B is going to be the square root of y squared, which is x and y. Okay. Right, that brings us to pretty much to the end of those. All right. Just an aside over here. If I have, for example, 0.125 x squared minus 1, what do we do when we see this red flag? Everybody hates decimals. You go, ugh, can't stand them. Change to a fraction. You'll see why. What is 0.125? Well, two ways. For those of you who want to do it quickly, type in 0.125 equals. It'll give you the fraction straight away. For those of you who want to do it a different way, that's 125 over 123 over 1,000, right? And then we're going to divide by 5. All right? So if we divide by 5, that's going to be 25. 5 is 200. 5 goes in there, 5 goes in there, 40. 1/8. So this is going to be, okay. Now can you see how much time you've saved by going 0.125 equals? It gives you 1 over 8 x squared minus 1. Difference of two squares, correct? What is that? Oh, no, it's not. Because that's not a perfect square. Okay? So that ain't going to work. Let's change it now. We've been through that. Let's just take it to what happens if it was 0.25. Okay? 0.25. You can factorize that previous one, by the way. Okay? That is going to be, never mind. Okay, we'll get to it. That's going to be a quarter. X squared over 4 minus 1. And that's going to be, a is going to be the square root of x squared over 4, which is going to be x over 2. And b is going to be the square root of 1, which is equal to 1. So we go x over 2 plus 1, double bracket, x over 2 minus 1. Right? And if we multiply out, what do? We put in our little bridge structures, and we will say x over 2 times x over 2, x squared over 4, plus x over 2. Okay, or rather, actually, let me do it in the correct order. Okay, minus x over 2, that one. Then it's plus x over 2, okay, and minus 1. That cancels out, and we get x squared over 4 minus 1, okay. There we go. That's now that one. The next section is going to be trinomials, where we're going to factorize a trinomial, okay? 3 terms. We're going to factorize that guy, and then we're going to head on to cubics after that. Okay, I am, of course, these are very intense, as you're getting. There's no sort of let's stop and chat and so forth. It's very, very intense sessions. That's why I'm trying to keep them down to short sessions. Thanks for watching. We'll see you when we do trinomials. Cheers.